15
Okay,
minutes.
so this will definitely help you guys out, especially if you don't remember when you do your homework, okay? So, what we are doing is the same rationals we've been doing. So we've got to remember how to simplify them, which is taking out your greatest common factor and simplifying those factors, okay? The first characteristic, and I put these in order based off of which ones they are anyways, because they go in order for a reason, okay? Not today. Okay, so what we are doing first is domain. It always comes first because if you guys think back to when you were simplifying, you always had to find what first? Domain restrictions, okay? You always found that before you simplified any of those factors, right? So if I'm asking for the domain, in order to find the domain, you're going to have to look for domain restrictions. How do we find those? Who remembers back to the test that we just had? How do you find domain restrictions? Denominator equal to and you got to simplify and factor first to do that, okay? Now, we're going to go over, there's some examples up there, but we're going to go over one by ourselves first. So did everybody factor number one? Does the numerator have a GCF or need to be factored or anything? Yes. What is our GCF? -2. If you didn't get the negative, that's okay, but it should come with it, okay? Because you want x by itself if you can get it there. What's left over if I divide by -2? Not x plus 2, it's going to be -2. You're dividing by a negative, so it's going to change your signs, right? Denominator, is it going to change? No. So it's just going to be x minus 3. So this is a pretty simple one. Can we find the domain restriction pretty easily with this one?
Yes.
How many are we going to have? Just one, right? So if I said this denominator equal to 0, what can x not equal, y'all? 3. So that's my one domain restriction, okay? This means my graph can continue on, but he has to stop or he does not exist at the line x equals 3, okay? I'm going to show you that visually, okay? Now, domain will always be what? Is it your x or your y-axis? Your x-axis, right? So the farthest side of your domain, what does the left side of my number line go to forever? Negative or positive infinity?
Negative.
So the farthest left side of my graph will start from negative infinity, okay? He's going to go along. You will always start with negative infinity with domain, okay? You will go from negative infinity, but it has to stop where it can exist, right? Where does it not exist on this graph? Positive 3, right? That's our domain restriction, okay? So it can go from negative infinity and then it has to stop because negative 3, it can't exist there, right? So then, this U, y'all never remember what that means? Union, like a marriage, okay? All of this stuff put together or union together is going to be your domain, okay? We are going to pick back up where we left off. Do I have any more domain restrictions or anything to worry about? No, so the far right side of my number line or my x-axis is going to go to what infinity? Positive infinity. Okay? So this is now my domain. That's it. You will always start with negative infinity and end with positive infinity. And your stops, I like to call it the train, my domain train. My stops are whenever I hit my domain restrictions, okay? So you always start here, end here, and this is going to be my, not my doctor, but my domain restriction, okay? It's not the doctor, but if you want to call it, sure. So I'm going to show you visually what that means on my calculator. I've graphed this on my calculator. You guys don't have to do it on yours, just look, okay? On my calculator here, this is that function graphed. So it's coming from the left side, but then it goes down really fast immediately, right? What was our domain restriction at?
3. Positive.
-3, right?
Yep.
Did I not put it right on here? Oh, I typed it in wrong. That's what I did. Please hold. I put +3 over here. My bad. Let me regraph that one. It'll definitely change it up a little bit. So, I'm coming from the left side, and then it still veers off, and it's veering off. If I put a line here at +3, both of them, are any of those lines crossing over that?
No.
Because it's a domain restriction. It's like a wall. Your domain can not go past this wall, so we have to stop, and then we pick back up on it, and then go forever to the right, okay? That's what the domain restrictions do to your domain a little bit visually. These also have another word and another characteristics. They're also called my vertical asymptotes. Vertical asymptotes. All right? So let's go back and do another example really quick. Did everybody do number 3?
Yeah.
All right, so what would can we do anything with the numerator?
No.
No, it's going to stay x. What about the denominator?
Yes.
There's an x, right? I can take an x out, and what's left over? X plus 1. X squared divided by x is x. X divided by x is 1. Anything divided by itself is 1. Okay? So how many domain restrictions do I have this time? 2, right? If I said both of these, remember it's anywhere you see an x in your denominator. You guys did really well with this on the test. Anywhere you have an x. If I set this x equal to 0, x cannot equal 0, right? What if I set this x plus 1 equal to 0? What would x not equal?
1.
What kind of 1?
1.
It's the opposite, remember. Okay? So, the domain, what did I start with last time, and what will I start with every time? Negative infinity. So now I have 2 stops in this domain train, right? So if I'm coming from the left side, who's going to come first? -1 or 0 on my number line up here?
0.
From the left side, I'm going to get to -1 because your negatives come first, right? So I'm going to go from negative infinity to -1, right? That's my first stop. To join them, I hit my union. I pick back up at where? Nope. I pick back up at, but my next stop is not positive infinity, it's going to be
0.
and then union 0 to infinity. I started with negative infinity, ended with positive infinity, okay? And I had how many stops this time?
3.
Well, technically 2 stops, but it ended up being 3 unions, okay? You will always have 1 more than how many restrictions you have. So here we had 1 domain restrictions, I had 2 parts of my union. Here I have 2 domain restrictions, I have 3 parts of my union, okay? So this is my domain. I started and ended with what I wanted to, and every stop in my train was a stopping and picking back up with a domain restriction. Okay? We good? Let's do 1 more and then we'll stop the domain, okay? We'll do 5 because I got a lot of space with number 5, so I like it. Let's do number 5. So y'all go ahead and factor number 5.
What?
I'll get you started on the numerator. Both of them you're going to have to do what? The x, right? Not cross multiply. Please don't cross multiply. I don't even know how you do that with this.
Hey.
I mean, you can try, but you won't get it right.
That's true.
So, I'm always about trying it. So go ahead and factor those for me. Anybody done with the numerator? And did my GCF go anywhere? Remember, he's got to come along as you're simplifying, right? What'd you get, Haley? X minus 4, x plus 2, do y'all agree? With the numerator? Nope. That won't be it.
It's x minus 2, x plus 1.
You're trying to feed for the numerator. Haley, you got a new one. What multiplies to give me negative 2 adds to give me negative 1. It should be what? Negative 2 and... So did factoring go anywhere? Are we still factoring? Unfortunately, yes. I heard it, but yes, unfortunately we still are. It will be here till the end, y'all. I'm sorry. But you'll be real good at it. Or still not good at it, but you need to practice. That's your decision. Remember, your A and C change when you take out a greatest common factor. What would the bottom one be? Negative 6 and 1. So that's got to be 3 and 2. Which one's negative?
Negative 2.
So it is x plus 3 and x minus 2. Now, does it look like I can simplify this rational further?
Yeah.
But do we do that before we find domain restrictions? No. You always find domain restrictions first, okay? Y'all hear me?
Yeah.
Before you cancel out anything, find your domain restrictions first. So who do I care about, numerator or denominator? So x can't equal what? Negative 3 and positive 2, okay? Let me give myself some room. I like to think that I can write small, but I can't. All right. So I got my domain restrictions. Can I find domain now? So who do I start with? What do I start with?
My bad.
Negative infinity, right? Who comes first on the number line from the left? Negative 3 or positive 2? Negative 3. Where do I pick back off at in my domain train? Negative 3. The next stop, is it positive infinity? I got another stop. It is.
Oh, positive 2.
Then union again, and then 2, 2. Do I have any more stops or domain restrictions? Nope. So I can finish and end at positive infinity. Okay? Any questions on this? So start and end with negative infinity and positive infinity. My stops on my train are going to be my domain restrictions. And I find those by setting my denominator equal to 0. This one's pretty easy, but he's always going to come first, okay? Because sometimes if we have to simplify, your domain restrictions will always be there even if I didn't simplify, okay? Because say for instance, you said, ooh, I see these two can get crossed out. And then you try to find your domain restrictions. What happens? Are you going to have both of them if you cross them out?
No.
No, you're going to miss one of them, okay? So make sure you are always finding domain before you simplify, okay?
Yeah.
He's about to stop recording too in a minute.
A minute.